So this is part 2 of our lesson. Once you've learned how to do empirical formulas and solve empirical formula problems, you're ready to move on to molecular formula problems. So finding out the molecular formula of compounds is a really important technique that's used in science. It can be used in pharmaceutical research, so trying to figure out a compound that could potentially become a drug for medical purposes. It could be identifying toxins in the environment. It can be used in forensics for identifying different samples. Um, so there's lots of different tools and applications of it. So even though we're learning kind of more the theory, the background behind it with some simple problems, the applications of this is quite broad. So how do we find molecular formulas? We need to be able to calculate something we're going to call the molecular multiplier. The molecular multiplier is a very easy idea. It's basically a number that's going to tell us how many times larger the molecular formula is compared to the empirical formula. Remember, molecular formulas will have the same or more number of atoms than the empirical formula. So, how we're going to do that? We're going to try and find the molar mass of our molecular formula. When we see MF here together, that's referring to molecular formula. This value here is always going to be provided to you in a question. Now, why is this given to you in a question? Because this number, that data, comes from an analysis that has to be done, and it's often done using something called a mass spectrometry machine or an MS machine. So if you ever see a molar mass given to you in a problem and you're trying to find out a molecular formula, they're telling you the molecular formula's molar mass. The other molar mass you need is the empirical formula. It's going to go in the denominator. This one will either be given to you in a question or you have to find that empirical formula and calculate it. Usually you calculate it. But we know how to find molar mass if we have a formula. So it's nothing that we haven't done. But if you do see a molar mass given, 99% of the time it's for that molecular formula. So we'll try out 2 more problems. We'll start off with one that's a little easier, and then we'll try one where we combine both empirical and molecular formula together. So this problem says we have a compound with an empirical formula of CH, and it has a molar mass of 39.06 grams per mole. What is its molecular formula? So let's break down what we're given. First thing that should stand out, they're giving us the empirical formula. So our empirical formula here is made up of 1 carbon and 1 hydrogen. That's definitely not our molecular formula, but we're going to figure out what it is. Next piece of data. It has a molar mass of 39.06. Remember I just said, if you're given a molar mass, it's going to be for the molecular formula. So this is the molar mass of our molecular formula. And using that number, we need to find out what is our molecular formula. We don't know. So if we want to find out, we need the multiplier. So our multiplier, we said, has to be molar mass of our molecular formula. And we divide it by the molar mass of our empirical formula. Now, what piece of data do we have? We have the molar mass of our molecular formula. This number up here, 39.06, is that top piece of the fraction there in our numerator. But what about the molar mass of the empirical formula? We don't explicitly have that, but we can calculate it. What's the mass of 1 carbon atom and what's the mass of 1 hydrogen atom? That's very easy. 12.01 grams per mole is for the carbon and we're going to add that to 1.01 grams per mole. That's the mass of our hydrogen. So together, we have a total molar mass of 13.02 grams per mole. That's our molar mass of our empirical formula. So the number that we're going to put on the top is this one here, and the number that we're going to put on the bottom for our empirical formula is the one we calculated because we had the formula to calculate it. So let's go ahead and put those ones in. 39.06 grams per mole. And we're going to divide it by 13.02 grams per mole. And when we do that, this is a nice easy number, it comes out to be 3. So what it means is this is our multiplier number. Our empirical formula is 3 times smaller than our molecular formula. So if we want to find out what the molecular formula is, we have to multiply our empirical formula by 3. So our empirical formula, remember we said, was 1 carbon and 1 hydrogen. To find the molecular formula, we need to multiply it by 3. So that means C3H3 is our molecular formula. So that's the simplest type of problem you could get if you're trying to find out molecular formula. Find the 2 molar masses. You're already given the empirical formula, so it's easy to find the multiplier and then multiply the empirical formula. Now, there's one more type of problem you can run into that's a little bit harder. And there's 2 steps that you need to do here. So, I've already written them down to give you a hint, but we're going to walk through these problems together. It says an unknown compound contains 55.4% carbon, 7.8% hydrogen, and 36.8% oxygen. Mass spectrometer analysis concludes that the compound has a molar mass of 390.48 grams per mole, and you want to identify the compound. If they're asking you to identify the compound, that means find the molecular formula. So, this question is different because they don't give you an empirical formula this time. They give you percent composition. So guess what? There's 2 parts to this question, and it's going to take a little bit of time to solve. So to find the first part of the information you need to find the empirical formula. And you're going to do that using the percent composition. So if you remember the empirical formula types of problems we just solved, you've got to do all of that. Assume 100 grams, find the mass, find the moles, find the ratio, all of that stuff. That's step 1. Once you have that, you will get your empirical formula and can find its molar mass. The next step will be finding the molecular formula. How do we find molecular formula? We need the multiplier. So, to do that, they are giving you the molar mass here of the molecular compound. So this one here is molar mass of the molecular formula. So what I'd like you to do to see if you understand this concept, pause the video and see if you can solve this problem on your own, and I'll walk through the answers next. So first part, find empirical formula using those 3 percentages. Ignore part 2 at first, just find the empirical formula, and then once you have the empirical formula, see if you can find the molecular formula. So pause it and see what you can do. All right, let's see how you did. So our first step is to assume 100 grams. We assume 100 grams. We'll be able to convert our percentages for carbon, hydrogen, and oxygen into mass. So, just like before, we are finding the masses. Then we know atoms and masses are related by moles, so we need to change these into moles. So we're going to divide by the molar masses. Molar mass of carbon, molar mass of hydrogen, molar mass of oxygen. When you do that, you'll get your number of moles, and you want to divide by the smallest number. So when you do that, you should notice it's not really helping you out much more. Here we go. This is our smallest number here of moles. So we're going to divide everything by that 2.3. And when you do that, you should notice the numbers are not nice and even. So we have to do that other trick from before. Multiply the numbers again to try and get as close as possible to the whole numbers. But after you do that, you should find if you multiply 3.36 by 3, it's pretty close to 10. 10.08 is pretty close. And then you should find that you have an empirical formula of C6H10O3. So that's the first part of the question. Step 1, find the empirical formula using the percentages. Once you've done this, and only once you've done this, can you actually go and find the molecular formula. So if you haven't tried it again, pause the video now, see if you can move on and try and find the molecular formula using that previous molar mass. And now you can find the molar mass of the empirical formula. And when you're ready, unpause. You can see the rest of the answer. All right, let's check the rest of the answer to this problem. So now that we know the empirical formula, we have the molecular formula's molar mass, we can find the multiplier. Now, if you want to calculate the molar mass of the empirical formula, you need 6 carbons plus 10 hydrogens plus 3 oxygens. When you do that, you should find the empirical formula is 130.16 grams per mole. That's the number you have to calculate. The other molar mass is what was given to you in the question. If you go back and take a look, it said the molar mass of the compound was 390.48 grams per mole. Now we have our two numbers to solve for the multiplier step. So we're going to put both of those into our multiplier, and you find out multiplier is 3 in this case. So that means we need to take our empirical formula, the answer from part 1, and we need to multiply all of those atoms by 3. So when we do that, 3 times 6 gives us 18 carbons, 3 times 10 gives us 30 hydrogens, and 3 times 3 gives us 9 oxygens. Yes, this is a long problem. It's a really big one to solve, but it's a good one to test out a lot of things in the unit and review so far. There's mass, there's moles, there's ratios, there's formulas. So practice away with your homework questions and make sure you post if you have any questions.